Okay, I'm starting back up with or without the rest of this group. So hopefully keep your voice down so I don't have to yell over you. Okay, so if you remember the first weekend we met, we had 2 assignments. We also have 2 for this weekend. The first one and the second one, we're looking at the first one for this weekend, which is the 3rd assignment. There's 6 total, 2, 2, and 2. I'm going to cover this one in class and we're going to do it right now. I'm not going to write it for you though, because at this point I want you to start writing your own code, but I am going to show you some examples that will look very, very similar to what you need to do, and talk about different ideas about how to implement the particular functionality. The next one is on a swing example, and we're going to hit swing next. So as soon as we get through collections, and we're going to go to swing. Swing's pretty fun. I've got some cool swing examples for you as well. So what you're looking at is an assignment overview of what you need to accomplish in order to show me that you've actually familiar with and you can actually work with the concepts that we've seen this weekend. These assignments aren't due, especially until like another couple months. I can talk about the due dates later. I don't actually have that information with me right now, but it's on the website. Okay, so the first one, number 3, is on stacks and queues. If you're not familiar with the data structure of a stack, let me just briefly, within 2 seconds, I can describe stacks and queues to you by using real-world examples. Stack of plates. When you take and unload your dishwasher or your sink, you know, where you pile up the dishes after you wash them, and you put them in the cabinet, you use a stack. You put one plate down, you put another plate down on top of it, another plate down on top of it, another plate down on top of it, and then when you go to take a plate out of the cabinet, you pull the top plate off. So the act of putting a plate on is a push. You push a plate onto the stack, you pop a plate off of the stack when you take one in to remove it. It's first in is the last out. It leads to starvation if you don't use all the plates. The ones on the bottom get dusty, you know. I'm sure you guys are all familiar with that. The ones on the top are all broken and shipped. So when the company goes over, you just switch the stack around, right? Anyway, that's a stack. A queue is what happens when you go to the bank. If they always helped the last person who showed up at the bank, the entire line would be like beating up that person. Instead, it's a first in is the first out. So last in, first out, first in, first out. So it's a fair kind of thing where the first person comes in, the next person gets on top of them, next person gets on top of them, and you remove from the different end that you put it in. So you put in one end, you remove from the other end. So it's first in, first out, last in, first out. So companies and people often buy stocks and sell stocks. They often buy the same stock for different prices at different times. So the prices of the stock, depending upon when you buy it, might vary. Say a person owns 1,000 shares of a certain stock, such as a Checkpoint. Is that a stock? I don't know. She may have bought the stock at an amount of 100 shares over 10 different times with 10 different prices. And you're gonna, it's kind of like when you buy on eBay actually. You buy some stuff, sometimes it's cheaper than other times, depends on when you buy it, how much you buy. You know, so you have to figure out, like average out what you're spending on that particular item when you're buying it, which is what you're doing in this program. Can we keep it down? Can we keep it down in the back? Thank you. So we're going to analyze 2 different approaches. So 2 different methods for accounting, first in, first out, last in, first out. These are accounting methods used, well, they also represent stacks and queues, for determining the cost of the stock. At any one moment of time, you can determine the cost by what order it appeared in the queue, in terms of what price you paid. Information is typically calculated when a stock is sold to determine if there's a profit or a loss. Alright, so we're going to get through this description. Alright, so looking at the first in and the first out, last in, last out, you may read the rest of the description on your own. It's talking about when you're buying stock, how much you're buying. You can keep this information in an array. You can keep it in a linked list. You can keep it in some sort of a list concept. So the first part of the assignment, you're going to be using a queue for storing the data in the first in, first out accounting, and a stack for the last in, last out accounting. You're going to create a data structure that's going to be a queue and a stack. You can use an array-based implementation for your stack. You can also use the collections class I'm going to show you. I'm not going to give you the code because it all looks the same. Actually, I have examples of it on the website. And unless I accidentally stumble upon it, I'm not going to give it away. If you look through the examples I have out there, you'll find both of them, actually. So what you're going to look at then is in terms of the implementation details. Here's some requirements for implementing your queue. Or you can use a programming method that you want to accomplish this task. Any programming method at all, as long as it involves Java. So both your stack and your queue should have records with the following fields: the name of the stock, string, the number of shares, the purchase price. The easiest way to implement this is to use a class. So you have a class, it's called stock. You make instances of this class object that's called stock, and you put them into an array. So you have an array of objects. And then each one of the items in the array is going to have a name, a share, a price. So you can keep track of all the stocks that someone bought. And then you can get each one of the items, and then you can calculate at any one moment at a time. This was the first one, this was the second one, this was the third one. You can implement the structure in an array, or you can implement it using one of the abstract data types I'm going to talk about in a few minutes. That's part of the language of the collections. So you can assume that there's a first element of the structure, and that's the security that's bought first. Security is a stock, by the way. And the second element is the one that's bought second, third, fourth. You can assume the order. Your program should have the user able to enter in information about the various different stocks, the amount of shares, and the price. And the user is going to either enter in a queue about the certain stocks, and then enter a queue about the certain stocks, and then the cost according to LIFO or FIFO, accounting methods, and the number of shares. The following could be your menu. Could be, doesn't have to be. Press 1 to enter a new stock. Press 2 to find the LIFO or the FIFO price of the stock. So how much is this stock? Well, it's going to be the first one or the last one in the item. So that's what, I'm sorry, that was pressed. Press 1 if 1 is pressed, you need to enter in the stock symbol. You can make this stuff up. It doesn't have to be real stocks. If 2, then the user is going to enter in the stock symbol being queried, and then the number of shares of the question is going to be brought out. Implement the program described above using a Java program. Any techniques that you want that accomplish this overall description. You can also have academic freedom to define different things that are not in this description if you want. You can make some more stuff up. You can make a different menuing system. And actually you can make a graphic if you want. After the next lecture when we talk about swing, you'll see how easy that is as well. So that's what we're shooting for. Not going to write it today, but I'm going to show you a few things as we go through. But the primary focus of today's lecture, or this one, is collections. So let's see how abstract classes and everything works into place. Well, we have java.util. So we actually, believe it or not, to this point we haven't included we haven't imported any packages. So a collection is a data structure, actually an object, that holds other objects. And so each will let us store and organize objects in a useful way. And we're going to check out java.util package. Lots of interfaces and classes providing a general collection framework. So now we're going to actually use some interfaces. And the reason why we're looking at collections is because we want to use abstract classes and we want to use interfaces and we want to implement what the people of Java have given us. And they've given us an entire util collection of this stuff. What's in this framework? And it's called a framework, very similar to the framework that we get with Facebook framework, Twitter framework, all the stuff we're going to see in Android when we start looking. In fact, I have a Twitter framework that will implement. Will we implement that? I don't know if it's on my list or not. Actually, we'll do it in the iOS class before we do it in this class, but it's the same concept. We implement the framework. It's using abstract classes that are given to us in another package. And then we make instances and we implement stuff. We'll see it with the views actually as well. So overall are the interfaces and the concrete classes. Concrete classes are the base classes in the collection framework. So in collection we have set and list. And then from set we have sorted set. This is the hierarchy of all of the classes in the hierarchy. Map has a sorted map. We have an iterator with a list iterator. I'm going to talk about iterators in a few minutes, maps and collections in a few minutes, and not a data structures course, just looking at from a programming, object-oriented programming perspective. Here's our root interface. Methods working with the individual collection. So most people would at this point would ask, how do you know what these methods are? You don't know. That's one of the hardest parts is you have to go online, you have to look up collection, list. And when we have pop, push, or we have stack, what do we have part of the list? And then we have all these methods that come out of it. And all the methods are used to implement the behavior. And the behavior is either going to hold items, remove an item, insert an item, or better yet, iterate through an item. So the iterator allows us to go through each one of the items in the list and see what's there. So it makes no point to actually go through every single one of these methods because not only do we just create tens of needless examples, but it would also be rather boring. So I'm going to kind of thumb through a couple of these slides here and then look at the collections and all of the different options that might be there. And come down to the bottom point here, and it says the SDK, or JDK, does not provide any direct implementation of the collection interface. It's a bunch of abstract and interface classes. So most of the actual collection types are implement this interface usually by the implementation and extension of interfaces such as set and list. So we're going to implement a set, we're going to implement a list in our examples that are going to be coming up shortly. So this interface is typically used to pass the collections around and manipulate them with a maximum generality, which means they're very generic. So part of the collection part from the beginning is what we're going to be looking at. The collections will use an iterator. So I have a collection example which will be a list, and that we're going to look at in Java in a few minutes here. And we also have another example that's an iterator. An iterator is an object that works on the list, that finds items in the list. So it's kind of odd, but we create an iterator, we put the iterator on the list, then we navigate the list through the iterator. It's all broken down into separate objects. Everything is object oriented. So the iterator. The collection interface defines an iterator method to return an object implementation, the iterator interface. So it can access the elements in the collection without exposing its internal structure. It's an interface. All we know about is the methods that we implement to go through this list and do certain things to it. No guarantee concerning the order in which the elements are going to be returned. We have to determine the order ourselves by what we have. So whether it's a sorted list or an unsorted list. So three defined methods in an internet. There are three defined methods in this iterator class here. In interface we have has, next, next, and remove. So we remove an item, take it out. We find if an item is next. Does it have another item in there? So, or we go to the next. Here's the classic routine of using an iterator. So public void, remove long strings, collection, integer, maximum length. So we send the collection to the method. It's a parameter of the method call that takes the collection and uses it with the iterator method. So we have iterator it is equal to collection. Well, that's this collection here, dot iterator. Which is the weirdest thing. I'd call this something else like navigate or something, navigator. But they call it an iterator because you're going to go through it. While it has next, and you're going, well, how did you know we had has next on the iterator? That's what I was trying to say before. We have this concept where all iterators have a has next, a next, and a remove. That's already implemented for us. We're just going to use the methods from the iterator. So we're not talking about interfaces right now. This is already implemented. And we're going to make instances of this here. It's another object in the hierarchy that we're going to use, just like system out, actually, or system. String, cast it to a string, iterator next. And then string length, is it larger than maximum length? Then remove it if it is. So don't worry about kind of like what's going on. We're going to see it live in a few minutes. But the concept of the iterator is what I'm trying to demonstrate here in terms of the functionality. So the iterator also has a list iterator. So the base class is iterator. So list iterator interface extends iterator interface. These are all implemented in the form of interfaces, by the way. Adds a method to manipulate an ordered list object during the iteration. So it's a list instead of just a collection. So it's a special kind of iterator that works. So this up here was a collection. So we took on a collection as a parameter, and then we applied an iterator to it. And that was to remove the long strings. So it was on the length of the string. So for our list iterator, we also have the same methods. We have because it's implemented on top of iterator. So it's going to overload has next, next, and next index to work with a list. And then we have previous index, we also have the remove, and we have the add. I'm not going to go through most of this because I'm going to see it live in a few minutes. But look at potential problems of list iterators and iterators. They do not provide snapshot guarantee. How do we know what's in the list when we send it to an iterator object? If the contents of the collection is modified when the iterator is in use, it can affect the values retained by the methods. So most of what we do in object orientation, especially with a dynamic language like Java, is during runtime. It's during while the memory is being manipulated and stuff. Iterators in general have a tendency to be wrong, to make mistakes. They make mistakes because they're working on static data in a dynamic environment, and they're assuming things aren't changing. Oh, and someone just got a phone thrown at them. No, I'm kidding. Okay. And the world's changing while the iterator is working. So here we have a Java language util library that we're extending from. This tells us we're using the collections. Collections are part of util. We have iterator test, and here in the iterator test we're going to create an array list. What's an array? It's a new data type. It's an instance of a class that we're going to create that's coming out of this Java util. I'm going to see this live in a few minutes. In fact, as soon as we get done with this example. Array list A is equal to new array list. A add, and then we have an iterator that's going on. And then the output's going to be 1, 2, changed. Because what we're looking at is iterator it a.iterator. Run the iterator method on A, which is our list, our array list. While it has next, string s is equal to a string, we'll get the it.next. If s dot equals 1, a.to set to 2 changed. So we're going to change it. It's going to output. This actually is not that big of a thing. Actually, it's printing it out in the right order. It's printing 1 to 2 changed. So it's not too bad. So snapshot will retain the elements as they are when the iterator object was created, which is unchanged in the future. If you really need a snapshot, you might make a simple copy of the collection, run the iterator on the copy of the collection. And then many of the iterators defined in Java util packages are also of the type of the fail fast iterators, which means they detect when the collection has been modified. If it's been modified while the iteration is going on, because the iteration is working on a snapshot of the information that's in the collection, and then lo and behold another method is changing the collection. When does that happen? All the time. Think of a banking application. If you're trying to do something on ATM transactions and each one of those objects that are coming through, you have an entire list, but transactions are still occurring again, tell the world to stop because you want to do a count right now. It's still changing. You're taking a snapshot and you're working with that snapshot, and then you can update the snapshot. So there's modes that you can put this in. Fail fast iterators update themselves, or they stop working. You know, they just cease to continue if something has been changed. When a modification is detected, other than risk performing an action whose behavior may be unsafe, they fail quickly and cleanly throw an exception. I'm going to talk about exception handling before the end of this weekend as well, where we have a current modified exception, which means our iterator changed. So here's an example. Here we have an import with Java util, class iterator2, public main. We're going to an array. They're going to create. We're going to do this in another example coming up here. A.add 1, 2, 3. Iterator it is equal to A.iterator method. A.add 4. We put 1 in here, but we created this one first. So then, while it has next, string, print out the string next. So we're going to have an exception because we created this, which gave us a snapshot, then we changed the list. This is what this is talking about in terms of what a snapshot is versus the list. So let's talk about a list. And then we'll see the list source code. Instead of writing it from scratch, we're going to just take a look at it and we'll go through it. We can modify it around stuff. But a list is an ordered collection which allows duplicate elements. So it's not an ordered, well, it could be an ordered, but it's a list. So it allows duplicate elements. Its elements indicated by a range of 0 to the size -1. Adds several methods to an ordered collection. So the interface list is implemented by two classes, array list and linked list. So most people from C++ are familiar, or C, are familiar with linked lists. And you know how much of a struggle that was to create a linked list if you did it manually in C++. If not, if you take my C++ course next term, you'll see how much of an ordeal it is to create one manually. Even if you use the standard template libraries, it's still kind of a tedious battle. But lo and behold, Java came along after C++ implementation and said, hey, you know what, let's just make this easier. Put it in a collections class. We'll just make an instance of this object, call it a linked list. We're going to see one in a few minutes, and you're going to go, I'm never going to program in C++ again after this. Because it's done for you automatically. So some people who originally, when the lecture started, oh my god, we're going to do data structures. Oh no, she's going to have us do a linked list. We're going to make one in like 5 seconds, actually. So, and it should be this easy in C++ as well, but for some strange reason it isn't. So, but the array list is a resizable array, so it's a dynamic array that's implemented in a list interface. So adding and removing elements at the end of getting the element at the specific position is simple. Adding and removing elements, I'm not going to go through the efficiency, this is not an algorithm course, but adding and putting one in the middle is more expensive. Can be efficiently scanned by using the indices without creating an iterator object, because we have arrays have index values for each one of the components that are in there. So it's good for a list which is scanned frequently but not added to and not changed, not modified. Linked list is good for things that are modified constantly but not scanned, because we don't have the efficiency of the data structure that's keeping track of the indexes. So we have pros and cons to both. Getting the element at position is more expensive in terms of efficiency. This is giving us big O notation. Take a data structures course if you want, or algorithms if you want to know about efficiencies and stuff. A good base for the lists were mostly for actions and not at the end of the list but in the middle of the list. It's more efficient. So let's take a look here. So we're going to build. In fact, we don't have to build it. We have it ready for us. So this is the collections files that I attempted and I successfully imported into the project here. And what I want to do is look at the simplest example here, which is going to be our list. So if you click on a list example as a starting point, I'm importing java.util. It's inside of collections, which is inside of the util. We know that we're getting the asterisk because we're getting everything at this level util. So we're getting everything. We could put collections in here. If I look at some of the other examples, I know I looked at this earlier and one of them actually had it. I could do it this way: Java util collections, Java util compactor dot Java util linked list, or I can simply just put util dot and the asterisk to give me everything in the collections. So let's go back to the linked list. So public class linked list example. This is the same thing that we've done before. This message here is because I haven't set the data type. I have not set the data type, and I'm kind of using a raw data type for this. We'll see the data type setting in a few minutes, but this is an easy example demonstrating the use of this list. So remember before out in main we created people and employees and cats and dogs and stuff. We didn't really worry about it. Well, it was all in the same package. We put it out here in the same directory structure. It was in the default package and we just loaded it up. This is the same thing we're doing up here if we do this. It's all in the same package. Now we've imported the package. So now that we've imported the package, what do we have? We have list. And there's an object called list. There's also an array list, there's a linked list, and a bunch of other stuff that I just talked about. So list is equal to new array list. So now we're going to create a list that's going to be of an array list type. So in there we have an array list. But it's going to be a list. How can we do that? It's kind of like saying the person is going to be equal to a new employee, but we're really treating it like a person because we're not going to use any of the array list functionality. We're just going to use the base list. List is on the bottom, then we have array list that's on top of that list in terms of the hierarchy. So I'm really doing a very similar thing to what we just did with that person and the employee in terms of, it's not object casting, it's just this is the reference, but it's referencing something higher up. But we're not going to use it because we're going to use it like a list. And list has things like add and remove. So here I'm adding 0, 1. Well, look at that, I put an integer in here. The simple list is expecting all of the same data type because it's not a dynamic array, it's an array list. So technically what I've done here is sort of breaking the rules because I'm using raw types and I didn't specify a type to use for this list. If I take this out here completely, suppress the message here, I'm going to get these little warning messages, and I've put my thing underneath it here. It says the list is a raw type, references to generic list, list E, which is an enumeration, should be parenthesized. Array list is a raw type referencing to generic type array list. Should be parameterized with this opening and closing bracket. So if I put my thing over here and I say, well, add the type argument to array list. Ooh, comparable. Interesting. And for generic type, let's do that one instead. I don't necessarily want to follow these guidelines here. There we go. Not the best solution. Actually, that's not what I really wanted to do. Let me undo this here. The next example has the type put in there. If I come down here, this will make it to a list. Add type argument for the list. No, I don't want to do it this way. So if we make it generic, I can just leave this alone. It's not going to cause any problem. The yellow is not an error message. The yellow is a warning because I've made this typeless. What we're going to do, and we'll see it in the next example, is use these opening and closing here sets to say that we want to create integers or say that we want to create doubles, but we'll stick it in different syntax and we'll see it as it comes together. So list.add0, list.add1, 2, 3, 4. So I did this raw because I have this number in here. I'm mixing and matching raw data types. So now I'm going to go system.out println my list plus the list. And then it's going to say, well, what's the list? Well, that's the array list. We can actually print out the array list like this instead of using a for loop to go through each one of the items. It looks like an array list, but then I can go to and then use it like an array list. But now I'm using a method instead of an array syntax. So now I'm using list.getTo, list.getZero to get the items out. And then here we go. This is what I wanted to do before, is actually give it a type. Because I'm mixing and matching the type for that list is not inferred correctly by the automated system. But down here we're going to do it correctly. I'm going to say linked list string, and we're going to call it Q. And the Q is going to be equal to a new linked list string. So string is the data type. If you're familiar with C++ and templates, standard template libraries, this is what we're doing. It's similar, except for we're actually using these classes, and the classes are inside of collections. And the class itself here, we're using a different one. It's called linked list. It's going to be equal to new linked list, and there's going to be strings. So now I'm using the strings here in this example. So Q add first, add first, add first, add first. So remember before I said first in, first out, we can add last. Actually, is there an add last? Well, we're just going to add first item, first item, first item. If we want to know what's available, we can go Q dot, wait for a little pop-up window to show up and say, well, we've got add all, add first, clear the list. Basic stuff you'd normally see, clone, clear, get close. So I was to say add, oops, not that, And then it should change the list as we're doing it. So if I say add all, add first, add last, here we go. Add last, and I'm going to put in here 100. So I've added this item as the last item instead of adding it to the first. So what you're going to do is you're going to create an object. So let's say call the object stock. I'm sorry. So let's add an object here, and then we can put object instances inside. So yeah, he's like, oh, excuse me. Just pardon me. All right. If we had an object that was person or something, we would put person in here. And then each one of them, instead of being a string, we'd make an instance of the object, stick the object in there. Like if it was P1 is equal to new person, let's just do it. Here, I'm going to add, so I told you I'd build this eventually. New class, I'm going to add it to the project here, I'm going to call it stock. I'm not going to look at the project description though, so mine's going to be slightly different. Don't need a public stack void main or whatever. This is here. In stock, I'm not even going to put any methods in here. I'm just going to use stock, kind of like a structure. I'm going to use it to hold the data that I'm going to put inside of the array. So instead of putting strings in the array, I'm going to put stock in the array. So the stock's going to be having an integer number, maybe. And this is a public. If I leave it out, it'll be public by default. And let's just put in here public integer quantity. So we got a number, maybe a description here, string, public string, oops, public string name. Oops, I know. That's why I don't type. Alright, so now we have stock. We have an object now called stock. So out here, it's in the same, I loaded it in the same project. So here if I wanted to, I can go, let's say stock, stock num1, stock 1 is equal to new stock. And we didn't actually set like anything in that stock. So yeah, let's just do it this way so I don't have any problem with it. Stock. Stock, this num is equal to 0. I think probably by default everything gets set anyway, right? This dot quantity is equal to 0. And then this dot name is going to be equal to apple. Maybe I should say Oracle because this is Sun. Let's go Oracle. Talking about Objective-C versus Java. Okay, not. Okay, there we go. So now this has got data set for it. So in here, I can do this and go, let's call this stock. Stock. Now I have a stock array, list array. So what am I going to put in here? Well, it's not going to take a number anymore. Instead, it's going to take a stock 1. So now I have item 1 loaded in there. Now, I'm doing this the slow way. I guess I could probably find another way of automating this a little bit. But let me just create 2 more stocks. Stock 2 is equal to new stock. I guess I could cut and paste as well. This is the old way of doing it. We could initialize an entire list. Actually, instead of these 2 stocks are going to be about the same here. So I'm going to go here, stock 2. This is what you're doing, by the way, for that assignment. Stock 1, stock 2. Questions? Stock 1. Whoops. Stock 2. I don't know, I just have 2 stocks and I loaded it up into the array. So you can create a stock Stock's got a name, a price, all that stuff associated with it. And you can add anything to it because the methods and the data itself can be accessed. Well, we're just going to print it. Actually, we can't really print it out. We don't have a print method. Oh, we could go back to stock here and add something in here. How about print? So public void print. And the print method is just going to print out the system out. Actually, all the data is going to be the same for all of these stocks. So, a stock. The stock is printed. At least we can see the method run when we run it further down the road. Obviously, you're going to want to return, set, and get the information for all of these items so that you can run this on your instance of your stock that got created that you're putting into your array in your program. So your program is simulating the concept of people buying and selling stock. So they're going to buy it at different prices and set it at different prices. So you're going to have setters and getters to get the price, set the price. Well, probably not set the price, but because when you buy it, there'll be a price. So maybe a purchase, which is going to be your constructor when you create the, so you'll have to have a constructor here that will essentially, I called it print. That's good. Well, which should essentially, I don't know, use the information in there. So to set the object correctly. All right, so I've run the methods on this, so I didn't actually have to create a linked list, and now I have the linked list. So I'm going to remove the last and then remove the last. So I'm going to print the queue. Well, if I print the queue, I'm going to get some interesting responses. In fact, I don't even know if that's going to work, really. So I might have to do something else because I've got objects in here. So if I wanted to, I can get to it. In fact, this list up here has got a way of getting to it. I can use the same sort of similar, but this is a linked list. So I'll leave it to you to investigate. Which is what the learning objective is to figure out, well, what do we have? If I print this out, I should get some memory addresses, but let's see what happens actually. I shouldn't get anything that's going to be too readable to appear on the screen here. I run it. Yeah, here's some memory addresses. So what I could do is make a method that says toString, and the toString takes the stock, maybe, and then translates the stock that's an object reference and prints it out as a string. So sometimes you see a toString method that's created that will convert these memories, and these are the items here. Stock at this, stock at this, stock at these are the memory. This is the items that are in my queue. So you're going to need to figure out how to print those items. If I do it this way, without using the linked list, I believe one of the other examples actually has you printing it out, so I'll wait with that one for a second. If I come up here and do the same thing, actually, let me cut and paste this, and let me put my stock up here. Move this guy up so I have access to it in this structure here. I can do the same thing. Here I can go stock 1 and stock 2 and stock 3. Oops, we don't have 2. Okay, 1. Here, actually, we'll just make 2 items. We only have 2 items anyway. And then in my list, I'm going to have the same situation. Eventually, I'm going to have to essentially, it doesn't really matter what I store this in. I'm going to have to convert the object to print out by string, so I'll have to do a toString method on it to print out the contents. We're going to see the toString in another example, so hold that thought on this one. But I think now you've got objects and they're in the queue. So this was 2 seconds and you have half the assignment done already. Actually, more than half. You got choices now. You can do it in a list or you can do it in a queue. Well, the queue is kind of a linked list queue, so we can end queue, remove queue, so we can remove last, add first, add last, remove first, maybe instead of removing last. Queue dot remove first. If we do that, we have a first in, We have a stack. We load it in, remove the first, remove the last, add to the first, add to the last. You can do them both with this. Because we're adding to the one end and removing from one end. This allows us to do both, actually. This is the doubly linked list. Yes, it is. So we can add and remove from both directions. But we didn't actually have to create any nodes or any pointers to nodes and nexus and all that other stuff that you normally get with a C++ linked list. If you've ever done one before, you'll look at this and go, oh, it just took away 3 hours of, or 2 hours of my assignment implementation. I don't have to create this linked list node, which is one of the beauties of Java. It actually kind of gives you kind of the abilities to do it. So I'm going to keep my stock because then I can use it in some of these other examples as well. But before I continue, this was the simplest list example that I could come up with. It kind of demonstrates the point. We're just using built-in objects list, array list, and linked list. And we're specifying sort of like a template class in C++. We're specifying the data type. So this one's going to be stock. It's going to be equal to new linked list stock that's going to hold stock. So this could be strings, integers, double, or like what I did up here and don't specify anything at all. You'll get some warnings because it's raw. You can suppress the raw warning, or you can actually give it a type and commit to something. If we were going to do that, we would use the same syntax here. So then in here I'd say stock. If stock was my type, but with a capital S, that would work. And then over here on the array list, we also put stock at the end. And now we've given it a proper type and all the warning messages go away. And then we are using the get, the add, the remove on the list. So when you get a list item, then what you're doing is you're running the methods on the item that's in the list. So for the item for the list, get to, what is it? Get to, once we've got list, get to, oh, I wonder if this will work actually. Print, it will work. No, we're going to have this in here mixed in with a plus. No, I have to, that's not going to work actually. I have to convert it because this is going to tell me that the plus operator is undefined for the argument type string void because this doesn't return. Print returns a void. It doesn't return a string. So it returns, this doesn't have a return. So I could go in here, let's say. And instead of void here, let's just say public string print, and then let's just have it print out. Do we have a string in here? We do have a string. Return name. So we've changed the method. Instead of void, now it's a print, excuse me, it's returning, which is what the toString is doing. So print toString. I know I told you I wasn't going to do it for you, but I guess I'm going to write it for you. So let's see what happens when we run this one. I'm going to take this one out so we don't have to look at this confusing input out here. And now we're just going to have this top one get printed out. Here, we'll even do it here. Well, it's going to be the same. We're going to get one that's going to print out something that's probably not going to be readable, so let's go ahead and run it. Ooh, we got a message. Main language, independent, list example. Index out of bounds. You know why? Because what are we printing out? 2? 0, 1. Let's make this one 1. And try again. Okay, so this is the first one. Remember we set the stock to Oracle? So I called it print. Here's what you get. In all of the textbooks out there in the world, let me change the name for a second here. All the textbooks out there in the world will do this. Make it to string. So I made a toString method, and the toString method, when I run it, it's going to do the same thing. So I'm leaving it print because the code is actually working, and I don't want to. I'm too lazy. I don't want to change anything. But what we're doing here is running something that's returning a string. We're taking the string, concatenating it with another string. And what are we doing here? List1.get first item. I know, quit complaining. I didn't save you. Oh. print with a capital P. Let me change it now to a lower. I mean, quit complaining. I changed it to a capital. Thank you. Actually, that would have taken me a few minutes to go back and look at it. So here I can go like this and go print as well. And then what have I done? I've essentially, well, I only have 2 stock here because my original one, my list, oh, we don't want to do this. I have to change that method to print it out because otherwise what we're getting is the objects, 1 and object 2. And then that's why we're getting this object. So now I've actually made it so if I run it, I should be getting 2 is Oracle and 0 is Oracle, but this is really 1 because I changed my index. So I want proper input, output, here we go. So 1 is Oracle and 0 is Oracle. We spent all morning looking at, well, not all morning, we spent some time looking at how to set and get information in the method, for the methods. So, okay, so yes, I have actually almost practically written your stuff for you. So this one does what? Returns a string from the object. Well, why don't we just return an integer and then we can get the number. What can we do with the number? And we can do something with it. So out here in our stock, we can write another one here that says public integer. What is this? Quantity. No, we don't have to put a price in here. Let me put a price in here. We'll do quantity. Quantity. I can't write your assignment for you completely. Quantity. Return quantity. So now I have a method that returns quantity. It's going to return an integer. So if I wanted to take that and use it out here, I could use anything that had to do with list.get. What item do I want? Let's say I just want the first one. And then I run a dot. Let's do quantity. Quantity. Well, what am I going to do that? I could do this. I'm going to say integer quantity, integer amount, let's call it amount, equals, put a little semicolon at the end of it, and now I've just gotten the amounts. What am I going to do with the amount? Well, what is it? Is the amount less than 5, greater than 5? Or take this amount, better yet, take this amount and add it to the amount number 2. So I can go here and go say plus list.get 1. Whoops, we don't have 1 in there. 1 dot quantity. That looks pretty good. And then, okay, so I'm here halfway. Let's just go the whole way. Paste. What if I set the quantity to 0? Maybe I'll change the quantity actually. Print total spent is, then just add it to the amounts. Because it's a string, we can concatenate a number to it, and it'll print it out as a number, excuse me, as a string. So let's go ahead and change the quantity here so it makes a little bit more sense here. So we go back here to the quantity of the stock. Instead of it making it 0, let's say we're buying them in 5 quantity increments, so we'll have 10 that gets printed to the screen. So if I run it, I have total spent as 10. So I have set some information in a stock that I've created, and I've put the stock in a list. I'm not going to write this for you, although I've come really close at this point. So you could possibly see where I'm going with here. You can do them both right in here. So just follow along the logic of the assignment. That's the assignment right there. And it's basically having you work with objects inside of array lists or lists. So let's look at some more, unless we have questions about a list or array lists. No? Okay, good. Can continue right along to this. We were on a list example. Let's look at a set, actually. Here's a set, and it's a hash set, actually, which comes from Java util. And so we have set object set equals hash set object. So we could add an object to it. Well, what does that mean? We can have any object be part of the set. So I could do this here and say stock my stock 1 is equal to new stock. Let's make another piece of stock here. And then put my stock in here, my stock 1. It's an object. Everything's an object. So now if I had a person and an employee, something else, I can mix and match data objects in here without having to make this raw. So instead of it being raw, now it's holding generic objects. So if I go back down to here, actually let me just do this because it's a little quicker and I don't have to mess up my project. I'm going to make another, I'm going to just go to this new file, new class. So I'm going to make another animal just because I don't have to do anything with the animal. I'll just leave it alone. So I have an animal in here. So in here I'm going to say animal, my animal is equal to new animal. So now I have an animal in here. It's okay, it's all objects. So if you didn't want a generic concept of a stock in this particular case, we could create Apple stock, Oracle stock. And if we had Apple stock and Oracle stock and Sun stock and ITU stock, although ITU is not publicly traded, we're not going to work. We're not going to ever have ITU stock. Then we could have all of these stock use an interface, and in the interface we would have all of the things for what makes a stock a stock. And so what I could see possibly here is creating an interface. I'm not going to do it because we just did that, but creating an interface, and in the interface we have a number, we have description, we have quantity, we have all these things that we're going to use, or an abstract class. Actually, it could be stock as an abstract class, and then have Oracle stock, Sun stock, ITU stock, and then having this data that's shared among all of them, and then the methods that are shared among all of them, either through an interface or through abstraction, depending upon how you want to do it. Both ways would actually be correct. And then here, if I had a method, I can go through and instead of in the last example where I ran print on everything, I could just run to string or print. And depending upon the implementation that was in each one of the stocks that we created, it'd run the right method. So I have generic behavior that's being printed out by a method that I'm running. I don't know what these things are. At one point when I come down here, let me go back to the list example because I have that pre-written already. Do I really know what's in there? Not really. If this was a plain old object and I created a print method on every one of my objects because it adhered to some sort of an interface and I put that in there so everything's got that, made sure everything had that. And part of that interface usage is just for the programmer to implement the right methods and remember to implement the right methods. Then I could just go through and print all these stocks out. So you could get a little bit more elaborate with it, create an abstract class, and then have different types if you wanted to. But going back to this example over here, it's pretty much the same, but it's using different data structures. What do we have here? We have a set. The last example was a list and an array list. And this one's going to use a new hash set. What's the hash set? We're going to add, and we're going to sort. So our set, we're going to print out the set. We're going to notice it's not going to be in any order. So I'm going to actually put back here 1 so we can see what this looks like. 2. We have 1, 2, 3, 4, and 5. And then we're going to, our set plus set is going to print out the set for us automatically. And we're just putting strings in here, so the strings are going to print out no problem. And then we're going to set the set, and then we're going to set, we're going to create a sorted set that's also holding these objects. That's going to be a new tree sort set. So we're going to take our set, turn it into a sorted set, and then we're going to say our tree set is going to be equal to this. Excuse me, not a sorted set. It's a sorted set, but it's going to be sorted by a tree. So let me run this so you can sort of see what I'm talking about. Say our set, and you're like, well, didn't I add the items in 1, 2, 3, 4, 5? Now I have 2, 5, 1, 3, 4. Because it's a set. It's not an ordered list, so the data structure itself is not keeping track of what order you put them in. So then I can take and create a sorted tree out of that. And that's going to go 5, 4, 1, 3, 2. It's a binary tree, it looks like. So it's going to go 2 levels and 2 levels. And so it's printing it out like a list. But it's really in a sorted. I could go, sort order, sorted list, or I could turn it into a list. Take the set, turn it into a list. Not such a good thing because then it's going to take this and turn it into a list. At one point I need to sort it now because I didn't sort it to begin with. So the list is keeping track of the order. The set, not keeping track of any order. We can also create a hash set where we can have key value, key value, key value. In that case, we can actually set this item, item number 1, key is this, value is that, item number 2, key is this, value is that. I don't believe I have that one. I might actually have it in another set of examples, however, I know it's in the lecture coming up as well. So the set is basically being translated, and so you see how we cast an object from one type to another. We can use a generic object, so it's kind of reinforcing some other points. Questions about sets? Oh, very good. You do, you can just holler. Linked list example. Just when you thought there was no more, we saw it already actually. So now we're going to create a linked list called LL that's going to hold integers. Simple linked list. And so this one here is different because it's showing the collections and the comparable. And we're going to actually put a comparator on it to compare one item to another, to search. We haven't searched for anything yet. And then the linked list itself that's coming in there. So we have add items to our linked list. We have these items in. And then the comparator, which is also of the type of integer, R, that's going to be equal to collections.reverse order. Well, the collections has, the main class in collections has the order, reverse order, a bunch of methods on it actually. It's an abstract class that's implemented by the other classes in the collection. We've seen it in the base hierarchy. And so we're going to create the comparator R from collections reverse order, collection sort, which is going to be another one. There's also a search method as well that we could add on that. So the system out is going to be print the list in the reverse order. So list sorted in reverse because we've taken R. That's going to be the collection reverse order, and then we're going to send to sort the linked list with R, meaning that's the order that we're going to search it in. So the comparator subclass in this hierarchy is using to compare one item to another item to another item to another item. Iterators are used to go through each one in the set or in the list. So it goes next, 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 or it does a comparison. Is this one equal to this one? Is this one bigger than this one? Is this one reversing that one? I mean, smaller than that one? So when we run the sort, we get the list in one order, and then we're going to put it into another order. And then here's the sorted list for I2 is in the linked list, system out, print I plus a space. So it's going to print out the list for us. And this is just a shortcut method. You can do this in C++ actually. It's the same kind of concept. Or you could make a big old list. But only going to be for the I's in the list. Print it out, and then we're going to run this one here, shuffle the linked list. Well, we just sorted it. Why are we going to shuffle it? Well, we put it in reverse order. Now we're going to shuffle it. It randomly relocates the items in the list in a different order. Okay, and then print out the shuffled list. So if we run this like 2 or 3 times, we should get different shuffles, depending upon the randomness of the items, and then print it out. And then go through and say, what about the maximum and the minimum? So on the collection, we're running a maximum and minimum. So anything having to do with comparing one item to another item is inside of this comparator object. We're running it on the collection. We're taking this guy back. Here, he was a linked list, but he's from collections. And he's going to be from a collections for the comparator. And the collection we're sending it is LL with the comparator that we're going to essentially sort. So we've got subcomponents that we're using together to facilitate this. So think of taking a list that you normally would do in C++, like a linked list, and inside the linked list you have a sort, and you have a minimum, and you have a maximum, you have a reverse, a random, a shuffle. Pull all that stuff outside of it. Make a separate object out of all that stuff. Send that object of the list to that other object, and have that other object sort it. Find the minimum, find the maximum, which is essentially what we're doing. We're just breaking it out into smaller components and sending them to each other. Stare at this one for a while. It might make a little bit more sense to you in terms of the implementation, but it kind of shows you the power of how you can easily put this stuff together. So I'm going to run it. So I see my list that was put into it, negative 820, negative 28. So the list sorted in reverse order is 28, negative 820. Okay. Well, we added it to it, but we didn't put it in any order. So we just reversed it, and then we shuffled it, and then we have the minimum and the maximum. It's still going to be the same numbers, 28 and 20. So negative 20 is the minimum, 20 is the maximum. So it just gives you an example about how you can sort of use it to automate. So it's some pretty sophisticated functionality that's done with a couple of method calls. Defining the minimum and the maximum, so sorting it stuff. And that was the linked list example. Here's an iterator example, which is kind of, again, simple in terms of implementation. The abstract concept's important to get out of it. What are we doing? We're creating an array list, AL. This one's going to be an array list. So what's an array list? Well, instead of using a linked list that's going to keep track of memory, and we're going to link the objects together in the memory, we're going to create an array out of this. But the array can grow. It's not as static as a dynamic array. So it's very similar to the dynamic array that you get in C++ if you use those template libraries. But A1, add a bunch of stuff to it. Again, using a raw data type. I'm not really specifying which type we want to use. Use an iterator to display the content. So it's going to go through the original contents of the AL. And then here's our iterator. We haven't seen an iterator actually in action. We've seen the comparator. But here's a iterator ITR is going to be equal to al.iterator, running the iterator method to turn this into an iterator. So in here we're going to go has next, has next, has next until we run out of stuff. So while we have next, which is very similar to a linked list actually, although this is an array list, object element is going to be equal to the iterator.next. So next just pulls out the element. System.out print the element. So element is what we're printing out. It's captured over here. And we're just going to print it out. And then modify the objects being printed. We're just going to put a plus next to it. And then the modified contents are going to be printed out. Basically using a couple of times through the iterator. Print out the list again. And then display the list backwards. So we're just going to go has previous, has previous, has previous. Because even though it's an array list, it's implemented like a doubly linked list because it's coming from the same. In fact, linked list is above it, and then array list comes below, is now inherited from that. So you get that plus a bunch of has next, well, excuse me, iterator has the has next and stuff, but you get all the functionality, so it's a doubly. So it has previous is in there too. So if I print it out, we get 1, 2, E, B, D, F, which is our list actually up here because I mixed and matched data types in it. And then modified list, we just added a plus to it and then put it out in reverse order so it reversed the list for us. So you're going to do this, you're going to play around with this for that assignment, and you're going to see if you can figure out how to put the pieces together. So, practically wrote it for you. So. Questions about the collections? In the lecture that I did not finish, but let me just show you because this is a little bit boring. It's easier to see it than it is to... We went through the examples here for set, sorted set. This is lecture number 6 if you're the type that needs to read about it. We actually saw all of this stuff. The map and the sorted map we did not see, but it's very similar. We're using, we didn't really see the tree. If you look at it on your own, it's very similar to what we've seen before. We also have synchronized wrapper in terms of the collection, and one thing actually to mention is we do have synchronized and unsynchronized methods that we work with this. So sometimes you'll see in the bottom here, let me talk about synchronizations for a second. Synchronized wrappers on collection classes contain static utility methods which can be roughly classified into two groups. They're wrapped collections or they're not wrapped collections. If they're wrapped, they're synchronized. So all the collections implemented that we have seen so far were unsynchronized. We have a form of synchronized methods. So concurrent access to collections. When do you ever have a collection that doesn't change? As I was mentioning before, we have a snapshot that's taken. We can synchronize it, and the synchronization is used the same way synchronize is used with thread processing in multi-threaded Java programs. In fact, if you think about C systems programming and compare it with Java, all that work with forking off processes, new thread, pthread libraries, we don't have threads. We don't have thread libraries in Java. Instead, we just use the keyword synchronize, and then it plays nice with everybody else. So we create a method with create a class, put a synchronized method in there that goes out. It looks at a piece of shared data that's going to be shared among a couple of different classes. If we make it synchronized, then we won't have starvation or deadlock, which means we will have each process will order themselves, and one will go in first, one will go in second, and we won't have any corrupted data that occurs with non-synchronized information. We have problems with non-synchronized information when two things try to access the same piece of information simultaneously. Happens with a list. We have one big old list that we're using in the program. Maybe it's a checkbook registry program and it's keeping track of transactions. Or maybe not. Maybe it's a list of students, and at any one moment of time someone might be printing out a report of these students or adding more students to the list. And the list is constantly changing because multiple classes are accessing it. So if we synchronize it, we're running the same collections, but we're running it with different words. We're putting the word synchronized in front of it. We haven't seen the word synchronized in any of our examples, which means they're all unsynchronized. Well, we've only had one process, our program, accessing that collection. We haven't tried to access it elsewhere. So concurrent access to a collection by multiple threads could cause indeterminate results or fatal errors. So you can synchronize wrappers, those collections essentially run a different set of methods, and access to the threads to prevent potential thread problems. Thread problems, take a systems programming course, or take a thread programming course and you'll figure out what the thread problems are, but it's inter-process communication among multiple simultaneously running threads, and we have race conditions, starvation, deadlock, all sorts of different situations that come up. Don't need to know anything except for the word synchronized. Synchronized sets, synchronized list, synchronized map, sorted map, synchronized anything in the world. Everything has a synchronized method that goes along with it, or synchronized name. For the purpose of this class, you don't have to worry about the synchronized method. And we also have, let me just make sure, we are going to take a break in a few minutes, don't worry. We also have a set of unmodifiable switches. So take that whole set of collections and consider we have a whole set for synchronized. We also have a whole set for unmodifiable. So unsupported operations exceptions can be drawn. We're going to look at, I'm going to save this for exception handling that we're going to hit probably not till tomorrow. But we have unmodifiable routers. Unmodifiable list is an example. And all these names, for some strange reason, were appended to the names of these methods. So and to the classes themselves. So it's kind of easy to remember. When you say unmodifiable, it means it can't grow. It's read-only. So abstract implementations. The collection framework provides a set of abstract implementations. So you design your own implementation with relative collection interfaces to satisfy your particular needs. We also have abstract collection, abstract set, abstract list. If we don't want the list, we can include our own list. So we can create our own array list that extends abstract array list, or abstract list actually in this particular case, and then implement our own add and our own remove. You don't have to do that for the assignment, but if you wanted to, you could essentially write your own array list implementation as well. Legacy collection types, we have a lot of them actually that are sticking around. So in terms of the package, the Java util also contains legacy collections. These are the old ones. So the set of legacy collections includes enumerations, which are analogous to iterators, vector, stack, dictionary, properties, hash tables, all sorts of different things in there. So I believe it's time for another break because it'll be the first one after the lunch break, and some people might need a bio break or something. Who knows what you need a break for. But let's take a quickie, and then we'll come back and look at swing libraries, our next topic on the list. So 10 minutes or so? 10? Okay, 10-minute break until we get back. Okay.